welcome to our channel Physics for AP. So today we are going to discuss about the chemical properties of acids and bases, and it's a fun time to have an experiment upon the indicators as well as the reaction of metals and metal carbonates. So here we have a HCl NOH, so we are having a methyl orange. As you can see in HCl it converted into red color, and sodium hydroxide it has been converted to yellow color. So the indicator which we are using is the methyl orange, and here we have the first one sodium hydroxide and the second HCl hydrochloric acid, and we are pouring phenolphthalein solution so as it converted into pink. And in HCl, as there is no change, that we call it as a colorless solution here. And if we add some amount of HCl into the phenolphthalein solution, there you can see gradually the change of the pink color, which converts into a colorless liquid. So again, by adding slowly, there you can see the change of the pink color. As we are neutralizing it, the sodium hydroxide and HCl gets neutralized, so it became a colorless liquid. The same also we will do for the methyl orange solution before with HCl and NaOH here. Now let us do the reaction with zinc and acid here.
Welcome back to chemistry. This is Jeremy Krug with another chemical reaction. This time I have a test tube set up here, and I'm going to add just a few milliliters of hydrochloric acid. Hydrochloric acid. This particular acid has a concentration of 6 moles per liter, so it's pretty concentrated. Then I'm going to take a little piece of zinc metal. I have this zinc metal in my hand here, as you can see. It's pretty shiny, just like most metals are, kind of silvery in color. And I'm going to drop the zinc into the acid. Now those are bubbles of hydrogen gas. I'm making quite a bit of hydrogen gas here. So I'm going to put this other test tube on top so I can collect as much of that hydrogen gas as possible. And since hydrogen is less dense than air, most of that hydrogen should stay in the test tube. If I touch this, I can feel that the test tube is getting very warm. In fact, it's quite hot. So this is an exothermic reaction. So I'm making quite a bit of hydrogen here. All those bubbles of hydrogen are being produced. Now, when I'm satisfied that I've made enough hydrogen gas, and I think I've made quite a bit, I will let this run a little bit longer. I think that's probably good enough. When I'm satisfied that I've made enough hydrogen gas, I'm going to lower this. And we'll come back to that later. Now I'm going to take that hydrogen that I've just collected, and let's see what happens when I take this little flame and set the hydrogen on fire. Did you hear the pop?
So as we have seen the experiment upon the indicators with the artificial indicators with the methyl orange and the phenolphthalein, and we have seen the reactions with the metals and reaction with the carbonates. Okay, so now we will be going to discuss about the chemical properties in detail. So the reactions of the acids and bases with the respect to metal oxides, the metals and carbonates and non-metal oxides of the bases. So now when we go into the reaction of acids with acids, so the acids react with metals. So when the acids react with metals, we will be getting salt plus hydrogen gas. So we have seen in the video that we get a pop sound, that is a gas when there is a reaction with acids and metals, so we get a hydrogen gas. So the examples we have here, as HCl plus zinc Zn, so gives rise to ZnCl2 plus H2, hydrogen gas has been released. And next, H2SO4 plus magnesium, that is sulfuric acid react with magnesium, we get magnesium sulfate plus hydrogen gas. As well as nitric acid reacts with calcium, we get calcium nitrate plus hydrogen gas is released. So the gas which is released here, so when you put a matchstick, we get a pop sound. So you get a pop sound with a flame. So with a flame, so the released gas, the gas which is released, can be confirmed that it is a hydrogen gas. So whoever or whenever anybody asks that the gas released in hydrogen gas, so can you prove the gas which is released is hydrogen? Yes, we can prove it. So when we put a matchstick, we get a pop sound with a flame. So then we can prove that the gas which is released is 100% hydrogen gas. Now let us see the reaction of acids with the carbonates and hydrogen carbonates. So when acids react with metal carbonates or metal hydrogen carbonates, so we get salt plus water plus carbon dioxide gas will be released. So examples, let us see the examples. When hydrochloric acid reacts with calcium carbonate, so we get calcium chloride, water and carbon dioxide. So at the same time, when we react the sodium carbonate with sulfuric acid, we get Na2SO4, that is sodium sulfate, plus H2O water and carbon dioxide. At the same time, as for nitric acid too, reacts with copper carbonate, we get copper nitrate plus water plus carbon dioxide. And also these are all the carbonates. So when it reacts with the hydrogen carbonate, or also we can call it as bicarbonate, so NaHCO3, which is called sodium hydrogen carbonate or sodium bicarbonate, so when it reacts with the H2SO4, so we get Na2SO4, that is sodium sulfate plus water plus carbon dioxide gas. So the released gas is carbon dioxide. So how can we say that the gas released is carbon dioxide? So as we have seen in the video, we have two experiments. That one is slaked lime converts into milky white, that is calcium hydroxide, when it reacts with the carbon dioxide. Actually calcium hydroxide, that is slaked lime, is a colorless liquid. So when carbon dioxide is sent into it, it turns into CaCO3 plus carbon dioxide gas is released. So this is a milky white precipitate. So we get a milky white precipitate. So it converts into calcium carbonate. So as slaked lime, that is calcium hydroxide, when it reacts with the carbon dioxide, so we get calcium carbonate, which is a milky white. So the solution which we have, which is a colorless liquid, had been converted into a milky white due to the passage of the carbon dioxide gas. So by this we can say that the gas released is carbon dioxide. And at the same time, carbon dioxide has a nature to put off the flame. So it put off the flames, as you have seen in the second experiment in the video. So it put off the flame over here, so the carbon dioxide. So by these two we can say that the released gas is a carbon dioxide gas. So when acids react with metals we get salt plus hydrogen, and when acids react with the metal carbonates or metal hydrogen carbonates we get salt plus water and carbon dioxide. At the same time, when acids react with the metal oxides, so when the acids react with the metal oxides we get salt plus water, that is HCl, hydrochloric acid, reacts with the magnesium oxide, so we get magnesium chloride plus water. H2SO for sulfuric acid reacts with calcium oxide, we get calcium sulfate plus water. And HCl, hydrochloric acid, reacts with sodium oxide, Na2O, we get NaCl salt plus H2O water. So in this reaction, as the acids are being reacting with the metal oxides, so here the metal oxides are basic in nature. So the metal oxides, these are basic in nature. So due to that, when the acids react with base we get a salt. Okay, so all the metal oxides are basic in nature. So when the acids react with metal oxides, so we get salt and water. And when coming to the reaction of bases, so the bases is the reaction with metals, as same also here. When the base reacts with the metal we get salt plus hydrogen gas. So here also the same, when sodium hydroxide reacts with the zinc we get sodium zincate, that is Na2ZnO2 plus hydrogen gas. And also the same, sodium hydroxide reacts with aluminum we get NaAlO2, that is sodium aluminate plus hydrogen gas is released. And the reaction with non-metal oxides, so when base react with the non-metal oxides we get salt plus water. So here the non-metal oxides, these are acidic in nature. So as these are acidic in nature, when it reacts with base it converts into salt. So here we have an example, that is sodium hydroxide. When it reacts with the carbon dioxide, that is non-metal oxide, we get sodium carbonate plus water. And also calcium hydroxide, when it reacts with carbon dioxide we get calcium carbonate plus H2O water. So we have two chemical properties of the bases, that is when the bases react with the metals we get hydrogen gas, and when the bases reacts with non-metal oxides we get salt and water. And coming to the acids properties, the chemical properties is when the acids react with metals we get salt plus hydrogen gas, and when the acid reacts with metal carbonates or metal hydrogen carbonates we get salt plus water plus carbon dioxide, and when the acids react with metal oxides we get salt and water. And coming to the next reaction, which is the most important thing, is the neutralization reaction. So neutralization reaction is the reaction which acids react with base to form salt and water. So when an acid reacts with the base, so this is the basic equation, that is the word equation. So when the acids react with the base we get salt and water, that is HCl plus NaOH gives us we get NaCl salt plus H2O. As if you see we get a double displacement reaction, that is the hydrogen which is present in this gets react with OH to form H2O, and at the same time Na combines with Cl to form NaCl. So here two are being displaced, so we get a double displacement reaction. And in the same case before, as if you see here in this one, as hydrogen is being displaced out, so it comes out and zinc gets replaced with the chlorine, so we get ZnCl2 plus hydrogen gas comes out, so which we call it as displacement reaction or single displacement reaction. So in this we call it as double displacement reaction, as both are being displacing over here. and when we see the neutralization reaction, we get a salt. But salt is also of three types, which is a neutral salt, acidic salt, and a basic salt. So let us see how those are formed. So neutral salt. So neutral salt can be formed when we have a strong acid as well as strong base. So we get neutral salt plus water, that is HCl plus NaOH gives us to NaCl plus H2O. And to get the acidic salt, here we need a strong acid and a weak base. So strong acid, weak base. As acidic nature is strong and basic nature is weak, the overall reaction we get a acidic salt plus water. So as if you see HCl, hydrochloric acid, reacts with NH4OH, ammonium hydroxide, we get NH4Cl, ammonium chloride plus H2O. And if you want the basic salt, so we make the reaction with weak acid and strong base. So as basic nature is strong and acidic nature is weak, so we get a basic salt. So we get the reaction as weak acid, that is CH3COOH plus strong base NaOH. So when it gets react, so we get CH3COONA, that is sodium acetate plus H2O, water. And also another also we get a neutral salt, that is when we get the reaction with weak acid and weak base. So CH3COOH plus ammonium hydroxide NH4OH. So when the acetic acid reacts with ammonium hydroxide, we get CH3COO NH4 plus H2O. So this is about the neutralization reactions. Now coming to the applications here, as we have discussed previous about the neutralization reaction. So in neutralization, as what we have discussed it before about the importance of pH value. So as we have discussed it here, the tooth decay. So as acidic nature is being formed in our mouth, to neutralize it we use a paste which is basic nature, which is one of the application for the neutralization reaction. As well as in digestive system, as excess amount of hydrochloric acid is released in our stomach, we use an antacid which is a base, which is milk of magnesium hydroxide. We use it as it is a base. We use it to cure the pain and irritation in our stomach. So this is also an application for the neutralization reaction. As well as the pH of soil, and also the bee sting. So bee sting, as they are formic acid, so whenever a bee is sting, so an acid is been released upon the where it is been stinged out. So to neutralize the pain we use a base over here. As well as wasp sting, so as they are in basic nature, strong base, so neutralize that we use an acid. So the acid which we use is a weak acid, not a strong acid here. And also nettle leaves. So nettle leaves also, they produce methanoic acid. To neutralize the methanoic acid, that is the pain of the methanoic acid, we use a base, so it gets neutralized and we get a salt, so we get a pain relief from it. So all these are the applications of the neutralization reactions. So now we have seen a video upon the reaction of the synthetic indicators, and we have seen the chemical reaction with the acids and metals, and we have seen the reaction with acids and metal carbonates. So any doubts regarding the chemical reactions or equations, so please give your valuable comment. Your doubts will be clarified. And thank you for watching the video. Please subscribe the channel, click the like button if you like it, and thank you for watching the video.